Hi everyone! In today's presentation, I'll be doing a comparative analysis of the three most relevant operating systems, Windows, Linux, and macOS, detailing objectively the main features of each one of these systems, drawing a parallel between them and demonstrating their primary use cases. Let me first give you a brief introduction to what operating systems are. Operating systems, or just OS, are fundamental software that manage hardware resources such as processor, memory, and disk, providing an interface for users and applications to function. Each OS has two main components, the kernel and the shell. The kernel is the central component where data is processed in the hardware. The output then travels through the software and reaches the shell, the outer layer which manages how you interact with the OS, providing system commands based on your input. We can group operating systems by what they are for, what devices they run on, and how they use the computer resources. Many modern operating systems share a lot in common, but they are set up differently for desktop, servers, or regular computing. A desktop OS is designed for professional and personal end users who interact directly with the system through a graphical user interface. Server operating systems are designed to manage network services and resources for multiple users. General-purpose OS are designed to handle a wide variety of tasks and workloads, combining both desktop and server characteristics. OS kernels are classified into five main types: monolithic, microkernel, hybrid, nanokernel, and exokernel. But here I'll focus only on those used by Windows, Linux, and Mac. In the monolithic kernel, used by Linux, all services like file system, device drivers, or memory management run in a single large kernel space. It provides high performance due to a low latency communication between components, but on the other hand, they are less fault tolerant, and a failure in one driver can crash the entire system. A hybrid kernel used by Windows and macOS has a combination of monolithic and microkernel architectures, keeping critical components and kernel space for performance while maintaining a modular structure. It benefits from balancing the speed of monolithic with the stability of microkernels. The downside is that the system can still crash if key parts fail. According to the website ElectroIQ, the current operating system market is dominated by Windows platform with 70%, followed by macOS with approximately 6% and Linux with 4%. Other operating systems, such as those for mobile devices like Android and iOS, make up the remaining 20%. These numbers can change a lot depending on how the systems are used, like in cloud computing, where Linux have 90% of public cloud infrastructure and nearly half of cloud work worldwide. Microsoft Windows is a widely used general-purpose operating system designed primarily for desktop, laptop, and enterprise environments. It emphasizes usability, broad hardware support, and compatibility with a large ecosystem of applications. This OS is structured into several key components. The first is the hardware abstraction layer that provides a consistent interface between the kernel and hardware, allowing Windows to run on a wide range of systems. The system kernel handles low-level tasks such as thread scheduling, interrupt handling, and synchronization. The executive services component includes core subsystems responsible for process and thread management, virtual memory, and I/O operations. The device drivers enable communications between the OS and hardware devices. And finally, the user mode component that includes system libraries, background services, and user applications that run with restricted privileges for stability and security. Windows is commonly used in the following scenarios: Personal computing, desktop and laptop usage for everyday tasks, productivity software, and multimedia. Enterprise and business environments, such as domain-based networks, enterprise applications, and centralized administration. Software development, development platforms supporting a wide range of programming languages and tools. And gaming, strong support for gaming due to hardware compatibility, driver support, and graphics API. In summary, Windows is a versatile and wide-adopted operating system that employs a hybrid kernel architecture to deliver performance, stability, and scalability. Its modular design, extensive hardware support, and broad application ecosystem make it suitable for both personal and enterprise use. Linux is a free and open-source general-purpose operating system kernel that serves as the foundation for many operating systems, commonly named as Linux distribution. It is widely used across servers, desktops, embedded systems, and cloud environments due to its flexibility, stability, and strong security model. As described before, Linux uses a monolithic kernel architecture with a modular design. Core services such as process scheduling, memory management, file systems, networking, and device drivers operates in kernel space. The kernel modules can be dynamically loaded and unloaded at runtime, allowing extensibility without requiring a system reboot. Linux is not a single OS, but a flexible ecosystem built around a common kernel. Distributions bundle this kernel with different system tools, desktop environments, and applications to serve specific purposes. This approach allows users to select a distro tailored to their needs, such as usability, performance, or specialized security tasks, while sharing the same core foundation. The most frequently used distros are CentOS, Debian, and Ubuntu. A typical Linux system consists of the following core components. The Linux kernel manages hardware resources including CPU scheduling, memory management, device drivers, and system calls. The system libraries provide the standard APIs that applications use to interact with the kernel. Shell is a command line interface that allows users to interact with the operating system and execute commands. System services or daemons are background processes that manage networking, logging, scheduling, and other system functions. Linux file system has a hierarchical structure that organizes files and directories, emphasizing permission and ownership. Linux is a dominant platform for web servers, databases, and cloud infrastructure due to reliability and scalability. It is a great environment for developers given its powerful command line tools, scripting support, and open source tooling. It is also commonly deployed in routers, IoT devices, and industrial systems. Desktop computing, used by technical users and organizations seeking customization and cost efficiency. In a sense, Linux is a high-performance open-source OS built on a modular monolithic kernel architecture. Its strong security model, flexibility, and scalability make it suitable for servers, development environments, and specialized computing environments. Similarly to Windows, macOS uses also a hybrid kernel architecture known as XNU. This architecture combines elements of match microkernel for process scheduling, inter-process communication, memory management with BSD components, responsible for file systems, networking, and user permissions. macOS is organized into several layered components. XNU kernel that manages low-level systems functions such as process scheduling, memory management, and hardware interaction. BSD subsystem, responsible for providing Unix compliant services that include networking, file systems, and user permissions. System frameworks, high-level APIs such as Cocoa and core services, used by applications to interact with the operating system. Device drivers, the I/O Kit, a modular driver framework that supports hardware communication. User interface layer. macOS is famous for its graphical interface, which displays very elegant and intuitive elements, allowing for a very pleasant user experience. This platform is commonly used for personal computing. It is also widely used for personal and professional. macOS is very popular also among developers due to its Unix environment and native development tools. It is the preferred operating system for video editing, graphic design, and audio production, and is frequently adopted in academic environments for development and research work. To summarize, macOS is a Unix-based operating system built on an XNU hybrid kernel. It's a layered architecture with a strong security module and tight hardware integration that makes it well suited for professionals, creative, and development-focused use cases. As we can see in this table, at a high level, Windows and macOS use hybrid kernels and focus on usability, while Linux uses a modular monolithic kernel optimized for flexibility and performance. Windows and Mac are proprietary, whereas Linux is open source, which enables much higher customization. All three platforms offer strong security, but though different models. Policy-based on Windows, permission-based on Linux, and sandbox-focused on macOS. Also, Windows and Linux support a broad range of hardware, while macOS is limited to Apple devices. Ultimately, Windows dominates general and enterprise use. Linux is preferred for developers and administrators, and macOS is popular with professionals and creative users. Now, let's summarize the three different memory management models. Windows prioritizes stability and predictability using a controlled paging system and configurable page files. In turn, Linux focuses on performance and efficiency, offering a high degree of control in management via kernel parameters. macOS focuses on automation and user experience, using memory compression and automatic swap management to reduce user intervention. When comparing the security model, we can state that Windows emphasizes a centralized security management, especially effective in enterprise environments. Linux focuses on strict permissions and transparency, giving administrator full visibility and control, while macOS prioritizes automatic protection and isolation, minimizing user involvement through sandboxing and system safeguards. Well, in conclusion, Windows, Linux, and macOS are all powerful and well-designed operating systems, but they are built with different priorities in mind. Windows excels in compatibility and enterprise adoption. Linux stands out for its flexibility, performance, and open source model, and macOS delivers a tightly integrated, user-focused experience for professionals and creatives. So there's no single best operating system, only the best choice for a specific use case. Understanding these differences allows users developers, and organizations to make informed decisions based on their technical needs and goals. Thanks for watching, and I hope you enjoyed this presentation.